Fredhom equation with separable kernel. An equation, the kernel of that equation k of x theta is said to be separable if it can be expressed as the sum of a finite number of times, each of which is the product of a function of x alone and a function of theta alone. That is k of x theta, that equal to summation n equal to 1 to n fn of x gn of theta. Fn of x is the function of x alone, gn of theta is the function of theta alone. For example, k of x theta, that equal to x theta plus x square theta. You know that this function have two variables x and theta. K of x theta equal to x theta plus x square theta. Okay, therefore k of x theta, another example, sin x plus theta. Consider the Fredhom equation is of the second kind with a separable kernel, that is y of x equal to f of x plus lambda into integral a to b k of x theta y of theta d theta, where k of x theta is separable. We can written as y of x equal to f of x plus lambda into integral a to b summation n equal to 1 to n fn of x gn of theta y of theta d theta. So y of x equal to f of x plus lambda into n equal to 1 to n fn of x integral a to b gn of theta y of theta d theta. Now the previous equation, that is equation number 3, have the function f of x is the form f1 of x, f2 of x, etc. fn of x are constants, but their values are unknown. Okay, f1 of x, f2 of x, etc. fn of x, and their values are unknown. If we introduce abbreviation, that is n equal to integral a to b gn of x y of x dx, then equation 3 can be written as y of x equal to f of x plus lambda into integral n equal to 1 to n fn of x cn, and y of x that equal to f of x plus lambda into summation n equal to 1 to n cn fn of x. Thus the integral equation 1, and it remains only to determine n constants, that is c1, c2, etc. cn. For this purpose we may obtain n equations involving this n unknowns, that is c1, c2, etc. cn are unknowns. For that, multiply equation 4 by g1, g2, etc. gn and integrating, then we get integral a to b g1 of x y of x dx equal to integral a to b f of x g1 of x dx plus lambda into c1 integral a to b g1 of x f1 of x dx plus lambda into c2 integral a to b g1 of x f2 of x dx plus etc. up to n. Therefore c1 equal to integral a to b f of x g1 of x plus g1 of x dx plus lambda c1 integral a to b g1 of x f of x dx plus etc. up to n. That is its remaining time. Here the first function is integral a to b f of x gn of x dx, lambda, second time lambda into c1 integral a to b g1 of x f1 of x dx. Okay, plus etc. nth time lambda cn integral a to b g1 of x fn of x dx. Okay, then 1 minus lambda integral a to b g1 of x f1 of x dx c1 minus lambda integral a to b g1 of x f2 of x dx c2 minus etc. that equal to integral a to b f of x g1 of x dx. We say this equation is E1. Then multiplying equation by g2 and integrating a to b, that is we get integral a to b g2 y dx that equal to g2f plus lambda c1 integral a to b g2f1 plus etc. That means c2 equal to fg2 integral f g2 plus lambda c1 integral g2 f1 plus etc. minus c1 lambda integral a to b g2 f1 dx plus 1 minus lambda integral a to b g2 f2 dx c2 plus etc. that equal to integral f g2 dx. This equation is E2 and that becomes minus cm lambda integral a to b gn f1 of dx minus c2 lambda integral a to b gn f2 dx plus etc. that equal to integral f gn dx. Okay, this is the nth function. First function g1, second g2, third g3 etc. gn. Now let alpha ij, then integral a to b gi fi, choose alpha ij and beta j that equal to integral a to b f of x gn of x dx. Then the above n equation e1 e2 etc. en can be written as 1 minus lambda alpha 11 c1 minus lambda alpha 12 c2 plus etc. that equal to is a b1. In a similar manner, the final equation is minus lambda alpha n1 c1 minus lambda alpha n2 c2 plus etc. We say that equation beta n. Thus the above system can be expressed in the matrix is of the form in minus lambda a into c that equal to beta. Okay, where in is the unity matrix of order n and a is alpha ij and a is matrix alpha ij and c equal to c1 c2 etc. cn, beta equal to beta 1 beta 2 etc. beta n. Now we discuss the possible solution of the system s is value of c1 c2 etc. cn. Next, suppose if the function f of x is congruent to 0 equal to 0 in 1, then the integral equation is said to be homogeneous. In this case the system equation will be homogeneous system. In this case we have the trivial solution c1 c2 etc. cn equal to 0. Thus the corresponding solution of the given integral equation will be y of x equal to 0. If delta equal to mod or determined in minus lambda that is not equal to 0, then the system has only the trivial solution c1 c2 etc. cn equal to 0. If delta equal to 0, then the solution is the trivial solution, and if we assign a arbitrary value for any c2, we can find out infinitely many solutions for the system 3, system S. Thus we have if f of x equals 0 in 1, then there may be the solution, trivial solution or infinitely many solution of y. Okay. Those values of lambda for which delta equal to determined in minus lambda a equal to 0 is called the characteristic values or eigenvalues. Therefore the function called characteristic function. Next, suppose f of x not equal to 0, then f of x is orthogonal to g1 of x, g2 of x, etc. Orthogonal means f of x dot g of x equal to 0. Then we have beta is again a 0 matrix. Equally, the system S will be homogeneous system. In this case also we can consider the above situations, and the solution of the integral equation 1 corresponding to the trivial solution c1, c2, etc. cn equal to 0 is given by y of x f of x. Y of x equal to f of x. Solution corresponding to the characteristic values lambda are now expressed as the sum of f of x and arbitrary multiplies of the characteristic function. Finally, if at least one right-hand member of the system E is non-zero, then we have beta is a non-zero matrix. We have matrix beta is a non-zero matrix in the system S will be non-homogeneous system. If del not equal to 0, then there exists a unique non-trivial solution for c1, c2, etc. cn, and hence there would be a unique non-trivial solution for the given integral equation 1. If delta vanishes, then there will be either infinitely many solutions for ci is corresponding, there must be infinitely many solutions of the given integral. Such cases we call the integral equation is redundant, and there will be no solution in such. We say that the system is compatible system. First system is redundant, and second is compatible. Integral first case redundant, second compatible. Okay.